Data visualization is essentially the art of turning raw, overwhelming numbers into intuitive pictures, such as charts, graphs, and plots. This allows anyone to understand the underlying story at a mere glance. In the fields of artificial intelligence and machine learning, we use visualization for two primary reasons. First, for understanding our data before we even begin the modeling process, and second, for communicating the results effectively once the modeling is complete. When working in the Python ecosystem, two standard libraries handle this task. First is Matplotlib, which serves as the foundational building block for plotting. To understand it, think of Matplotlib as a blank canvas with basic paintbrushes. It gives you absolute full control over every pixel, but it inherently requires more manual effort and code. On the other hand, we have Seaborn, which is an upgrade built right on top of Matplotlib. You can think of Seaborn as a professional artist's toolkit complete with pre-made templates. It is significantly more efficient, allowing you to create beautiful, complex charts with much less code. Let's ground this in a practical business scenario. Imagine a sales director at a retail company who just received a massive spreadsheet containing 12 months of sales data across 50 different cities. If they choose to analyze a table of 600 individual numbers, it is incredibly mentally taxing and slow. However, if they instead view a single well-designed bar chart, it instantly reveals exactly which city is the top performer and which month had the lowest sales. Why is the chart so much better? Because the human brain processes images 60,000 times faster than text. Visualization acts as a spotlight, revealing hidden patterns that are practically invisible when looking at raw data sets. Choosing the correct visualization is critical, governed by what we call the golden rule. The right chart answers your specific question instantly, while the wrong chart just leads to confusion and potentially disastrous decisions. Let's look at the 6 fundamental chart types and how they apply to real-world questions like analyzing weather patterns. A line chart is best used for tracking trends over time. For instance, it perfectly answers the question, how did the temperature change over the last 12 months, by showing a clear rising or falling trajectory. A bar chart is ideal for comparing discrete categories, effortlessly answering which city is the absolute hottest this month. When you need to see the distribution of a single variable, you use a histogram. It groups data into buckets, telling you exactly how many days had temperatures in specific ranges. To reveal relationships between two different variables, a scatter plot is perfect. It plots individual dots to help us see if, for example, humidity heavily affects temperature based on clustering patterns. A box plot is excellent for showing the overall spread of your data and spotting outliers, answering what is the spread of temperatures and were there any extreme days. Finally, a heat map visualizes the correlation between all columns simultaneously, using a color grid to show exactly which months and cities are correlated in terms of heat. The key takeaway here is that visualization isn't just about making data look pretty. It's about choosing the precise graphical tool to instantly uncover and communicate the hidden story within your numbers. As we move forward, we will see how massive companies in media and banking rely on these exact same visual tools to drive their core business strategies.
In the media industry, companies like Netflix use these tools to drive strategy. They use line charts to track viewership growth, bar charts to compare content by language, heat maps to identify peak engagement times, scatter plots to see if episode length influences completion rates, and box plots to see rating distributions across genres. Similarly, in banking, as seen in the ICICI Bank case study, visualization helps monitor loan health. Histograms show the distribution of credit scores, while box plots can reveal that certain employment types have more salary outliers, those unusually high or low values. Heat maps can show if two variables like loan amount and property value are highly correlated, meaning they move together so closely that a model may only need one of them. This allows teams to identify high-risk segments before spending months building complex models. To implement these visualizations, we begin with a Python script. We import standard libraries for numerical operations, data handling, and plotting, applying a clean professional theme to all our plots. The code creates two data sets. The first represents 12 months of sales and returns for a retail company. The second generates random samples of customer ages, order values, and ratings to provide enough data for complex statistical plots like histograms and scatter plots. Now, let's look at the outputs. The first plot is a line chart designed to show sales trends. We plot sales with a solid line and returns with a dashed line, adding a legend so the viewer can clearly distinguish between the two. The second plot is a bar chart to compare regional performance. We add up all sales for each region, placing regions on the x-axis and total sales on the y-axis. Notice how the exact sales figure is placed on top of each bar, removing any guesswork. Moving to the bottom left, the third plot is a histogram, showing the distribution of order values. We divide the values into bins and add this red vertical dashed line to represent the average order value. This helps the viewer to see at a glance if most orders are above or below the average. The fourth plot is a scatter plot, exploring the relationship between customer age and spending. Each dot represents one customer and they are colored based on the department they bought from. If dots cluster in a certain area, it suggests a relationship between age and spending habits there. The fifth plot is a box plot, used to see the spread of order values by department. The box represents the middle 50% of the data. The line inside is the median. The whiskers show the normal range. And these single dots appearing beyond the whiskers are outliers. Finally, the heat map represents a correlation matrix. It calculates how much numeric columns relate to each other. A value near +1 is a perfect positive relationship. 0 is no relationship and -1 is an inverse relationship, making it very easy to see which variables are strongly linked. With these foundational visualizations understood, we can apply them to real-world scenarios, like summarizing energy generation data across different regions.
To really see how we apply all these skills in practice, let's step into an energy sector challenge. Imagine you are an analyst at Tata Power, and management hands you this raw data set of monthly generation data. As you can see, we have the number of units generated for solar, wind, and coal, along with geographic regions and unit costs. Looking at raw numbers in a pandas data frame is overwhelming. So our job is to summarize this data visually for management so they can actually understand it. First, we need to understand how production fluctuates throughout the year. A line chart is perfect for this. By plotting all three energy sources over a 12-month period, we can easily spot the seasonal trends. For example, following this yellow line, you can instantly see when solar generation peaks during the summer months. Next, management might ask, overall, which source gave us the most power this year? To answer that, we sum up the yearly data and use a bar chart. This gives us a direct side-by-side comparison where it's immediately obvious that coal provided the vast majority of our total generation, towering over the totals for solar and wind. Now let's dig into the economics. We want to know if generating more solar power makes it cheaper. A scatter plot helps us answer this. We place the cost per unit on the vertical axis and the solar units on the horizontal axis. Notice this clear downward trend? This tells us that yes, higher solar production strongly correlates with a lower cost per unit. Finally, we need to check if pricing is fair across different areas. We use a box plot to visualize the spread of costs across the north, south, east, and west regions. This chart shows us the median costs, the normal ranges, and helps us spot if any region has an unusual price spikes or outliers, like this one specific data point hanging far below the rest in the west region. By mastering these visualization tools, you have completely transformed how you work with data. You have learned how to take raw, messy data, run it through visual analysis, and turn it into clear, actionable insights. Whether your final goal is identifying high-risk bank loans, optimizing Netflix's content, or managing a national power grid, You now possess the essential skill of turning complex numbers into the clear visual patterns that drive real-world data-backed decisions.